Hi, welcome back to Unit 7, Day 3, proving quadrilaterals are parallelograms. So, guess what that means? We are going to do a proof, okay? This is kind of an involved proof, so you're going to stay with me. And if you have any questions, please make sure you join the sync time. Ask anything you're unsure about, okay? So let's look at our givens. Given the measure of angle MJH equals 24 degrees. The measure of angle JAS equals 24 degrees. So I know I have two angles that are congruent. The measure of angle MHJ equals 30 degrees. And the measure of angle HJS equals 2x degrees. And x equals 15, which I know if I plug that 15 in for x, 2 times 15 is 30. So I'm going to have two pairs of congruent angles. Okay, so hopefully that's going to help us prove that quadrilateral JMHS is a parallelogram. The first thing I want to do is sketch a picture so I can see where those angles are, right? Because otherwise I'm not sure. So I have quadrilateral JMHS needs to be a parallelogram. I don't know for sure if it's a parallelogram, but I'm going to sketch it as if it is a parallelogram so that we can try to prove that it is. Okay? So when I sketch it, I'm going to sketch what looks to me like a parallelogram. And when we name it JMHS, I can start at any corner I want and put my J. And then from there, I have to walk around the edges. I can't go diagonal. I can't go JM and then put my H over here on the left, because JM, if I put my M here, I can't then fall into the diagonal of the lava to get over to H. If I go JM, I have to go along the side, and my H has to go here, S. Okay, so JMHS, I could have started in this corner, JMHS. The key is that you go around the edge when you label it. And normally we go clockwise, but I could even go JMHS. It's okay to go counterclockwise. The key is that you go along the edges of the shape when you name it. You never cross diagonally when you're naming. Okay? All right, so now let's see what we've been given, and let's start building our proof. So first it says, given the measure of angle MJH is 24 degrees. I'm going to write that in here. The measure of angle MJH equals 24 degrees. That's been given to me, and I'm going to add that to my picture, because as soon as I can see some stuff, I'm going to want to start trying to write that. Okay? So MJH, MJ, and then H is along the diagonal to get to H. So this angle here is 24 degrees. Okay, I just marked it in my picture because if I can see it, it kind of helps me a little bit. Okay, then my next given is the measure of angle JHS is 24 degrees. So I'm going to write that down. The measure of angle JHS is also 24 degrees. That is given to me. JHS, that's going to be this angle here, is 24 degrees. So those aren't really opposite angles, right? I know if I'm trying to prove I have a parallelogram, if I can show opposite angles are congruent, then I can say, yes, I do indeed have a parallelogram because both pairs of opposite angles are congruent. But I don't have the whole angle. I just have part of the angles. But if you remember back to what we were looking at in the notes, if I think of JH as a transversal, these angles here are alternate interior angles. And when alternate interior angles are are congruent, then I have parallel lines, or in this case, segments. So I'm going to actually put that in my proof now while I'm thinking about it before I move on to my next given, right? I've already used those two givens. So I'm going to, while I've got just this marked in my picture, I'm going to add that to my proof. So I'm going to say that these two angles are alternate interior angles. So angle, MJH, and angle, JHS, are alternate interior angles. And that is given by the picture that I drew. You could also say it's the definition of alternate interior based on my picture. So either one of those I would take. Okay? So then if I take this first line here, the measure of angle MJH equals 24, but then I say, oh, but 24 is also equal to this, so I can substitute those in. I can say equals the measure of angle JHS. I just substituted in the JHS for the 24 because they both equal 24, so I substituted. So I have these alternate interior angles. They have equal measures, so that means I can say JM is now parallel to SH. JM is parallel to SH. Okay? If you don't remember that symbol means parallel, you probably should write it off to the side somewhere, right? Segment JM is parallel to segment SH because alternate interior angles are congruent. Okay? All right, so now we've got one pair of opposite sides are congruent. So we can prove two other things, right? When I look back at my opposite sides being parallel, I'm either going to be proving both pairs of opposite sides are parallel, which means I need to do what I just did one more time, or I need to prove that the side that I already proved is parallel, that also they have equal measures. Okay? Since I don't have anything about side measures, I'm pretty sure I'm going to be proving both pairs of opposite sides are parallel. But let's continue on and look. My next measure of angle given is measure of angle MHJ is equal to 30 degrees. I'm going to check that off that I used it, and I'm going to mark it in my picture what my given was. So MHJ, so that's this angle here is 30 degrees. Then my next one, the measure of angle HJS, is 2x degrees. HJS equals 2x degrees is given to me. So HJS, that's this angle here, is 2x degrees. Okay, so I'm looking at these two angles, and those two angles, if I use the definition of alternate interior, I can see that these two angles are alternate interior to each other. So angle MHJ is, and I should say, angle HJS are alternate interior angles. And I can either say that was given to me by the picture I drew, or I can call it the definition of alternate interior angles. Okay? I can put either one. It's been given in the picture that I drew, or I'm using the definition of alternate interior angles. Okay? I would take either one of those for that one. But now I can't do what I did on the next one. The next one I did the substitution because both of these equal 24. That means they have to equal each other. But here, both of these don't equal 30, right? One equals 30, one equals 2x. So I need to figure out how to make this one equal 30, which means I need to use that last given, x equals 30. So now I can substitute it in to the HJS. Measure of angle HJS equals 2 times 30, substitution. Property of equality. Okay, and then I can do my simplification and multiply those together. Or sorry, 15. I messed up here, right? This is 15. X equals 15 was given. My brain was thinking ahead. So now the measure of angle HJS does equal my 30 degrees by simplification. Okay, remember that's not the multiplication property of equality, even though I'm multiplying. Multiplication property of equality means I'm multiplying on both sides of the equals. I only multiplied on one, so this is just simplification. Okay, So now I can say that my two angles are equal. The measure of angle MHJ is 30 and HJS is 30. So the measure of angle HJS is equal to the measure of angle MHJ because they're both 30. MHJ. And remember we said they were alternate interior angles, and now we've shown they have the same measure. So since my alternate interior angles are congruent to each other, oh, and this one was substitution, right? POE. Now I can say that these two angles, or that these two sides, because my alternate interior angles have equal measures, that means they're congruent, I can say that since these are both 30, my alternate interior angles are equal, these two sides are parallel. JS is parallel to MH. JS is parallel to MH. JS segment is parallel to MH, and that is using the fact that my alternate interior angles are congruent or equal. Allows me to say that those two sides are parallel. So now I've got the top and the bottom are parallel. I've got the left and the right are parallel. So since both pairs of opposite sides are parallel, guess what? That means my figure, my quadrilateral, is a parallelogram. Quadrilateral JMHS is indeed a parallelogram. Okay, and that is what I was trying to prove, that quadrilateral JMHS is a parallelogram. But remember, we don't write prove out here. We need to know which of these theorems, which of the 5 theorems did I use to prove it. I said I proved that both pairs of opposite sides are parallel. So this is the theorem that allows me to say that quadrilateral is a parallelogram because both pairs of opposite sides are parallel. Are parallel. Okay, so there is my final proof. I have proved everything they've asked me to prove. It's a little bit involved, but we got it done. If I can get that clear for y'all, as clear as possible. Okay, if you have any questions on that, then make sure you do indeed read through it, watch the video again if you need to, and then attend your sync time so that you can ask any questions that you might still have on proving quadrilaterals are parallelograms. All right, thank you so much for watching.